we will first set up a session and create a client UI. Here we can see that each client UI has two main frames. The first one is for test input, and the second one is for delay controller. And next we will demonstrate how our system works in the scenario of slide 10. To demonstrate this scenario, we will create 3 client UI, Alice, Bob, and Xi. Okay, so first we will briefly introduce how this delay controller works. As we can see, there are 2 test fields here. For each is for username, and the other one is for one of it is for username, and the other one is for delay setup, which means we can use this 2 test field to set up our delay to each other user. For example, we would like to set up the delay from Alice to Bob as 2 seconds. We input the username and the corresponding delay in each test field, and we can see that set up Xi to 5 seconds. We can see from this table that the corresponding delay to each other user. We input the AB in topic, and we can see that Bob's topic is changed after 2 seconds, and Xi is changed after 5 seconds. And of course, we can use this no delay button to set up all the delay to all the users back to 0. And we can see that the topic is changed immediately. Okay, so next we will show how our system works. We'll first set up the delay of each user pair. First, Alice to Bob, 2 seconds. Alice to Xi, a bit longer, 1 second. And Bob to Alice, 2 seconds. Bob to Xi, 2 seconds. And Xi to Alice, 1 second. Xi to Bob, 1 second. Here we will first do not use the causality function, which means we will not check this checkbox, and to see what will happen. First, the Alice will input down. After receiving this message, Bob will input launch. And after receiving each message, Xi will answer the questions. And here we can see the interesting thing. These 2 messages from Alice and Bob is showed perfectly the same in the Bob's UI and Alice UI, but the order of these 2 messages is reverted in Xi's UI, which means these answers are not consistent. So, what we will do to correct this error? We will open the causality function. And to see what will happen, down, launch, and the answer. Okay, so here we can see that the message are shown perfectly the same in all the users' UI, which means this system is demonstrated correctly. Of course, we can see the trace from the console. here is Alice, the Victor timestamp message sent, and the local count increment, timestamp incremented, and message sent. And from the Alice, the message received, buffered, removed from buffered, delivered, and remote count incremented timestamp. Okay, so next we will show how our system works in the scenario of the slide 14. In order to save time, we just skip the delay time setup step, and the delay time is set up as follows. David will receive the message from Alice in a short term, just 1 second. Yeah, also from Cassie 1 second, and also from Cassie from 1 second, and Cassie will, the Bob's message will arrive at Cassie very fast, 1 second, and the other delay time is 10 seconds, which is a relatively long time. And first we will see how the system works without causality. We let the Alice input the message Alice, Bob to input the message Bob, and after receiving the message from Bob, Cassie will input the message Cassie. And after wait for a moment, we can see that the message is very messed up. It's quite messed up, right? Which means each order of the messages, the order of message showed is totally different. And what will the system do if we open the causality function? Check. Also Alice, Bob, C. So now what happens? We can see that Alice and Bob both receive their message from each other, but David only received the message from Alice. This is due to the concurrent message, which is delivered from both Alice and Cassie. Here we can see from the trace in the console that there are concurrent Victor timestamp message detected. For example, when Alice first sent the message to David, the message timestamp is 1000. And after the Cassie received the Bob's message and sent her message to David, David received the message step is 0110. And so if he receives the message from Alice first, then he cannot process the message from Cassie. Okay. So when we just turn off the causality function, we can see that this message stored in the buffer will be processed immediately. And if we check the causality checkbox again to open the causality function, we just resize the timestamp from David, and we input another Alice. We can see that David cannot receive the message from Alice because Alice's message timestamp now is 2000, but David is 0000, so he cannot process the message. So how we can process the concurrent message, we will show next. Okay, so next we will show how our system will address the concurrent message problem. The delay time set up as the same, and here we let Alice input the message Alice, Bob from Bob, and Xi from Xi. And what we'll see, we can see that after receiving the message from Alice, Bob can process the message from Xi and Bob. David can process the message from Xi and Bob. Although the order of message from each sender are not consistent, but the concurrent message are processed. Okay, let us show the third scenario. The time delay is set up as this, and first we will let Bob enter Bob, Alice enter Alice, and Xi enter Xi. And after a while, we can see that the order of message is messed up, and here is the result of no causality, and we check the causality. And do the same, Bob from Bob and Alice and Xi. So now we can see that after received the message from Alice, David cannot process the message from Xi, and of course there is we can see from the trace that there's a concurrent message detected, and next we will show how our system can address this concurrent message problem. Okay, here the third scenario, we address the concurrent message. Cancel, check, and we first let Bob input Bob, Alice input Alice, and Xi input Xi. And after a while, now we can see that David can receive all the message from other three users, and Alice, Bob, and Xi, and can also receive the message from each other, although the order may not be totally the same. So that's all. Thank you very much. Okay, next we will show how to put causality into the Windows share system. First we set up a session and create 3 client UI, Alice, Bob and C. Oh, sorry. Here, each client has 3 windows. One for test view input, one for pointer controller, and another one is delays setup. It's for delay control. And here we can see that the time pointer the movement of time pointer is shared immediately. And if we set up some delay, for example, Bob for 2 seconds, we can see that after 2 seconds, Bob's telepointer will move. And now we just set up C to 10 seconds, and we will show that first we let Alice to increase the telepointer, and after the Bob receives the telepointers change, he will change the telepointer again, and now we will see that C has not received the cracked telepointer sharing action. And this is the situation when we have not choose the causality function. Now we will use the causality function, check. And here we will try that again. First we let the Alice to increase the telepointer's size, and let Bob to decrease. And what we'll see? Increase, decrease. Yes, exactly the same action. And that's all. Thank you very much.